Hi everybody. So today we're going to talk about compound and interest and exponential growth. Okay. So first we're going to talk a little bit about simple interest though. So simple interest is interest that is paid only on principal. So if you put $5,000 in the bank, your principal would be $5,000. If you were getting 10% interest, you'd get 10% of that. So that'd be $500. You'd get that every year on your principal. Okay. Compound interest is a little different because on compound interest you get interest on your interest. So you get, like in that example, you would get your $500 interest the first year, but then the next year you would get interest on $5,500, and so on as it built up. So you get more interest if you are being paid compound interest. Now, if you're paying, like if you're paying on a mortgage, those are always compound interest. You're going to pay interest on that interest as well. So you're going to pay a little bit more. Now, the compound interest formula is A equals P times 1 plus R over N to the NT power, where A is the amount of money in the account at time T, P is the initial principal, R is the interest rate, N is the number of times the interest is compounded per year, and T is the time in years. Now, generally, it's better to be paid, you get more money if you compound more times. So if I was to compound the interest daily, I'm going to end up with more money than if I compounded it quarterly or yearly. Okay? It's not a whole lot, but it is more. Okay, and all other things being equal, if you're going to get more money, then you want to get more money, right? So, you deposit $1,000 in an account that pays 8% annual interest compounded quarterly. What is the balance after 5 years? Okay, so here we go. I'm going to write down my formula. I always write down the formula on every problem. Okay? So I deposit $1,000, that's my principal. Okay, and then 1 plus my interest rate is 8%, so that's 0.08. I'm compounding it quarterly, that's 4 times per year. And I'm going to have that, I want to know what it's going to be worth in 5 years. Okay, so there I've got my formula all filled out. So I'm going to grab my handy dandy TI-84 plus C Silver Edition graphing calculator, or a reasonable facsimile thereof. 0.08 divided by 4 is 0.02 plus 1. So this is going to be 1,000 times 1.02 to the 20th power. 4 times 5 is 20. Okay, so I'm going to take that to the 20th power. That's going to be 1,000 times 1.4859 and some change. Okay, and then I'm going to go ahead and multiply that by 1,000. And I'm going to end up with $1,485.95. Okay. That's going to be my balance after 5 years if I don't touch it. Now, the interest that I earn is the $485.95. Okay, my principal is the 1,000. All right, so pretty simple. So on this one, you got $5,000 deposited in an account that pays 6% annual interest. Find the balance after 25 years if the interest is A, compounded quarterly, and B, compounded monthly. So I tell you what, I'm going to let you pause the video here and give this a little try. And then when you're done, come back on and start it up and take a look and see if you got the right answer. Okay, so again, for both of these, this is the formula. Okay, take that. Put that over there. Okay, so on this one, the amount is going to be $5,000  1 plus, my rate is 0.06, here I'm compounding it quarterly, so that's going to be over 4 to the 4 times 25 years. Okay. Now over here on this side, okay, on this problem, we're going to have 5,000 times 1 plus 0.06 over monthly, so that's going to be 12. What's going to happen here is I'm going to get less interest per month, or I'm going to calculate the interest. I'm going to get a little bit of interest, but I'm going to get it more times. Okay, so this is going to be 12 times 25 years. Okay. So you can see this is going to be a smaller amount than this is because I'm dividing by 12 instead of 4, but I'm going to do this many more times here than I am here. Okay, so let's get out our calculator, and this is going to be 5,000 times 1.015 to the 100th power. Okay, so then we'll take this to the 100th power, and that's going to be 5,000 times 4.432045. And then we'll go ahead and multiply that by 5,000. And that means if we don't touch this money, we're going to have $22,160.23 in our account. Okay, now what happens over here? 0.06 divided by 12 plus 1. This is going to be 1.005 to the 400th power. Oh, 300th power, sorry. Okay, there we go. So you can see this number is slightly less than this, but this number is a lot bigger than that. Okay, so 1.005 to the 300th power. This is going to be 5,000 times 4.464968. So then I multiply by 5,000, and I'm going to end up with $22,324.85. Okay, so you can see I ended up with what, about 180 bucks more, 160 bucks more, $164 more if I do the compounded monthly than I do the compounded quarterly. Okay. You've inherited a house that was purchased for $20,000 in 1950. It is now 2024, and the house appreciated in value by approximately 5% each year. What is the value of the house now? Okay, we can use compound interest. So we'll write down our formula. Okay, so my principal would be 20,000. My rate is 0.05. It's compounded annually, so that's 1, and then it's how many years? So 74 years. Okay, so this simplifies here a little bit to 20,000 times 1.05 to the 74th power. So I'm going to go ahead and grab my calculator, 1.05 to the 74th power. So this is going to be 20,000 times 36.9835. So times 20,000, that house is now going to be worth approximately $739,670. And you can put the 21 cents on there if you want to. Okay? This is what compound interest does for you. This is also kind of what homeownership does for you. You can make a lot of wealth over time. Okay? Now, you'd think $20,000, that's not a very expensive house, but in 1950, that would have been, you know, the average house was about $6,000 or $7,000, so that would have been a pretty nice house at the time. Okay, exponential growth and decay. So let A and C be real numbers with C greater than 0. The models for exponential growth and exponential decay are as follows. Y equals C, A to the X is exponential growth when A is greater than 1. Y equals C times A to the X is exponential decay when A is between 0 and 1. So, if I look here, Y equals 3 times 1/2 to the X power, since the 1/2 is being compounded, okay, it's the thing being taken to the power, halves of halves of halves keep getting smaller and smaller. This is going to be exponential decay. This is going to look like this when you graph it. Okay? This, 2 times 3 halves. 3 halves is more than 1. So 1.5 is take this to the power, it's going to get bigger and bigger and bigger. So this thing is going to have exponential growth. This number out here in front, this coefficient, it doesn't really matter what that is. This could be 10 million out here, but if I'm taking something to the half power over and over and over, eventually this is going to shrink down to be almost nothing. Okay? It'll never be nothing, but it'll be as close as I want. This number can be a little teeny tiny number, and this eventually is going to take over and make it a big number. Okay. So to test whether a solution is a base or an acid, chemists created a test called the pH test. This measures the concentration of hydrogen ions in moles per liter in a solution. Okay, so the concentration of hydrogen ions equals 1/10 to the pH power. Okay, so here's what you have, you know, if you kind of have a range, you have hydrochloric acid has a pH of 0. Okay, stomach acid a pH of 1, lemon juice a pH of 2. So these are all acidic things here. Vinegar, tomatoes juice, coffee, milk is a little bit acidic. Pure water is right in the middle, it's 7. Okay, that's neither acidic or basic. Now, when you get bigger numbers, egg whites, baking soda, this is becoming more and more basic. Okay, ammonia, washing soda, oven cleaner, which is 13. That's very, very basic. It'll burn you just like anything acid will. And finally, sodium hydroxide is at 14. Okay, so the question here is how much more acidic is a solution with a pH of 3.5 than a solution of pH of 6.5? Okay, so I'm going to go ahead and take 1/10 to the 3.5 power over 1/10 to the 6.5 power. Well, this would be, I subtract my exponents here, this would be 1/10 to the -3 power, which is going to be 1,000. So this item here is 1,000 times more acidic. Okay. So I got a little assignment here for you. Enjoy that, and I will see you next time.